Greetings everyone. Today we'll be discussing generations of languages. Uh, Let me ask, when you see the topic generations of languages or generation, what comes to mind? What comes to mind when just by seeing generation? Anything pops into mind?
All language, old time language, things like that, generation,
Over the years, over time.
history.
History. Well, yes, typically that's what it's about, and yes, and close enough. When you think about generation, you think about heredity, genealogy passing down from one to the other. Generation that typically comes to mind, you have a son, your son, you're a youth, and you have a family. Sort of thing.
Yes,
Now, generation, now, languages, there have been, over the years, as I mentioned, there have been many developments that have taken place in the field of software engineering. If you can recall the last lesson that spoke about high level and low level languages. Now, as you can see where there has been a transition, and that is because persons have realized that there needs to be improvements, there needs to be solution to different problems. As a matter of fact, that's the very essence of science. And if you go to a science class, the first thing that you're taught in science is that science was there to make life easier. That's the first thing you're taught in high school, that science, and that is why it's called computer science, because it is there to help to make life easier. Now, there are about five generations of languages, 5 different generations of languages. The first and second generation of languages are put in the same category. These actually refer to the same machine languages that were developed in the 1950s, 1960s, the same machine, similar to what we taught in the last lesson. Of course, Charles Babbage actually came up with mathematical calculations. If you took from the very first lesson, the problem solving, we start off with some maths. So this is why I said that when you think about the concept of programming, think about the concept of maths, it's the same level of reasoning, it's the same set of the brain that you use to process it. It has a lot to do with logics and reasoning. The intent that we want to bring across here and for the lesson is that at the end of the day that you will be aware of the different generations, and I'm going to point out something very important as to what causes languages to even survive throughout the generations. And that's really the essence of it, to understand the different generations that exist and of the world itself, programming, what is required. Now, as I said before with low-level languages, these languages, even though they could be quickly compiled, because there was no special, it's actually machine languages. One downside is that it wasn't portable. As I mentioned last, machine languages were never portable. They were simple, but then the construct of it was the particular hardware that it was being run on. So you're going to find that is one of the downsides to it. So this kind of program is still considered fast, and to program in machine language required high knowledge of CPU and machine instruction set. This also meant high hardware dependency and hence lack of portability. Now, this is what brought us now to third generation languages. These were made in the 1960s. The emergence of it, they had to develop higher level languages that were not so dependent upon machines. You have Algol, COBOL, Fortran. I must point out that COBOL was made for business persons. It was considered to be a programming language for business people. Fortran, on the other end, was for scientists, persons who specialize in physics, like Albert Einstein, etc. Persons that were interested in building air jets and aircraft, aerospace engines. Now you find that these languages, of course, they are compilers. So now you see where they move to machine independence, that you didn't need now to, you would never have an issue of portability, that at one point you have to then to reconstruct a brand new code to run another machine. So hence you had compilers, specialized softwares that were built to avoid you having to have to restructure the entire code to run a different machine. So you find that one benefits that came with this, it was easy to learn, easy to grasp, there was portability, simplified bugging, because I talk about moving from zeros and ones to then to a place now where there's something more near to English that you could understand and therefore be able to debug, check for errors and things like that. Now, the fourth generation of languages, I said quite clear that it must be user-friendly. So you find that it took its time to evolve over the years. So from one state of being pure zeros and ones, hard to interpret, quick for the machine to run, to now something that was more machine independent, something that human beings can more relate to, and then a further transition to something that was more user-friendly, that even persons who were non-programmers were able to use. It wasn't as technical as what you would anticipate. And this is where you have a Pascal. Now, it's having intelligent default options about what the user wants and allows the user to obtain results fast using minimum requirement code. So you find that here it was not so technical. As a matter of fact, one thing about COBOL is that COBOL was very wordy. So you find that many business people, and this is why you find that even today, COBOL is considered to be the most used language. And even though there's many hype about Java, and I'm going to explain as to Java is a new language that came out in 1994 by Sun Microsystem. You find that even though there's that hype about Java, you find that COBOL is actually still the language that is being used. Now, we saw PL1. I'm going to touch some more on that. So you find there's an evolution of languages. Example of these are IBM's APL, CPS, ASPOT. So these were examples of fourth generation languages that were more easily understood, easily interpreted, could be used user-friendly. Now, I want you to pay keen attention to this. I have it here, reasons for failures of certain languages like PL1. Now,
What is PL1?
exactly, we're going to that now, because I mentioned Fortran before, I mentioned COBOL now, and you saw just in the price of fourth generation languages that PL1 was mentioned. Now, PL1 was actually a language that was designed to merge COBOL and Fortran. So what you'll find is that COBOL was meant for business people, Fortran was meant for scientists. So what they wanted was to build one overall program that instead of the scientists having to then go to Fortran, they wanted us to put everybody in one gap. And importantly, and you can all relate to me, have you ever seen it in life before where there are things, it sounds like a good idea, it looks like a good idea, but when you actually get to the intricacy of it and put the plan to work, you find that it's not feasible. And if you have ever identified yourself with it, it sounds like a good idea. Hearing it, it feels like a good idea, but when you actually put pen to paper, it's not feasible.
Yes,
No,
sure.
Now, interestingly, I listed out some things here, and if you are interested to go further in the area of IT, these things are going to come back to you. Never forget these things. Especially when you get into the area of IT, software engineering, never you forget these things. Orthogonality, as I have it as the principles of language design. Orthogonality, conceptual integrity, ease of use, portability. If you construct a language and it doesn't contain these languages, you have just constructed a failing program.
Sir, these are languages that
Can be
language that we are
constructed.
developing must contain.
Yes, these are what a language must possess.
Also, these are not language then.
No, these are actually principles of language design. These are what a language must contain, must possess for it to be good under any circumstance. If you go on to your degree, these things will come back echoing to you.
So, sir, what are the generations of language?
It has a lot to do with the evolution of language from one family to the other in terms of from a low-level language to a high-level language. I spoke about first-level languages being like the assembly language and the machine code, and then I spoke about the evolution of it. Now, I mentioned this because this has a lot to do with programming languages. Anyone have ever heard about Windows Vista?
Yes, sir.
Windows Vista. Would you believe me if I tell you that Windows 95 made more sales than Windows Vista?
Okay.
More sales.
But why, sir?
Exactly. Because of planning. If you develop a program or an operating system that is not very friendly, it doesn't support a lot of features, you're looking at a failing operating system. Now, orthogonality.
What?
Orthogonality, mentioned right here. If I develop a program or a language, and when I look into the language, some of it look like C, some of it look like COBOL, but at the end of the day, and when it produces a result, it produces gibberish. You have just failed the orthogonality test. Because the test of orthogonality speaks to you being able to develop a program that you're able, that it produces, that it is consistent. That's what it speaks to, consistency. If you write a program, it must be consistent. I should be able to look at it from top to bottom and be able to see where it makes sense, and at the end of the day, it should produce a value. That it shouldn't be a value that is unpredictable. It should be, you should see a level of consistency. If I give you you remember from lesson 1 with the issue of problem solving, you remember that lesson?
Yes.
If I had given any one of you the Pythagoras theorem, the trigonometry question, and you came with the answer and you couldn't show the clear steps on how you derive at the answer, I would want to believe that you are cheating.
Okay.
Would it be fair for me to tell you are cheating? If you come with the answer, you just come with the answer, you never outline the clear steps, I would want to think that you have cheated. True or false? Would it be fair for me to believe that as a teacher?
Yes, sir.
Because how you come with the answer? Exactly. Conceptual integrity. Conceptual integrity speaks to the fact that I should be able to, when you write an algorithm, I should be able to look in each function, whether it be an if statement or a loop, and be able to see where it fits into the overall solution.
Sir, I have a question. Question, sir. Do we have to study that for the test coming up next week? Do we have to study that?
Well, it is important that you grasp the concept, because what we're teaching here is for you to grasp the concept. Because as long as, I'm going to tell you the truth that you see the CXC exam, it is easy. I have no friends who literally swat the paper. As a matter of fact, I've actually, just recently I had doing driving practice, and you may got a grade 2. And I asked him a question, he was stumped. And I said, what happened? I'm saying, you know that, I swat the paper. I can almost guarantee if you take the paper 3 years ago, paper the year before that, and paper for last year and swat the paper, you almost guarantee pass. Probably get a
Also,
grade.
that might come on our CXC test.
Well, to understand the concept of it, the concept, you will very well come back to see it in the actual exam. Not only that, alright, to how the CXC is structured, you may necessarily go in depth, in detail in these things. But when you decide to go on, because you have many persons that they SWAT, get a grade 2, but it's when they go on to college, it shows on you that you didn't learn anything. Because CXC is more of memorization. And there it is very easy for you to memorize, to put SWAT and don't get you.
So my question is, of what generation is this one? Because I know you told us that you're going to learn about the generations
Yes.
of programs. So those 5 is in which generation?
Well, these are the principles that for every language and every language need to have to be. So now you understand why you have to move from one generation to the next because of portability issues, ease of use issues, conceptual integrity in terms of you being able to identify, and this is one of the main issues of machine languages.
Yes, sir, we get that, but no, what are the generations of language?
Yes.
Also, so what you're saying is that as every generation they improved on those concepts.
Exactly.
Oh, yeah.
Exactly.
Okay.
Exactly. And this is why I said here that this speaks to why language like PL1 fail. If you know what I had in bold, why languages fail of languages like PL1. These are some of the failing points why certain languages never go forward. COBOL actually go forward over the years because it was easy to use. And then they have now made object-oriented COBOL, which puts it on the same level of C++, but now make it much more compete with C because it's more easier to use and now you're able to now develop objects from it. Now find the 5th generation of languages actually speaks the languages that I've written a program in Prolog before. They have made now almost very basic now that you just type in a line of code and it does everything for you. So 5th generation of languages actually speak to languages that they are more their internal classes, internal functions that all you have to do now is just type in a word and then the program does everything for you. So instead of you having to have to worry about a bunch of if statements, you just enter in a line and it does everything.
Oh.
Like for example, Prolog. Now the importance of this was for the whole issue of artificial intelligence, fuzzy logics and neural networks. The world's actually going to a place now where we're trying to build machines that can reason and think like a human being. So this was to make ease of building of systems that can actually do that. Of course, these principles have failed over the years, and it's for the same thing as I said to you before, that there are things in life, it sounds like a good idea, but then when you actually get down to it, it isn't. And what you may find is that what is solved in theory, in practicality is not solved. And one of the reasons why artificial intelligence hasn't gone where it beyond now is that it is machines cannot learn. And it is very difficult. One thing that human resources are precious resource. Because with human beings, we're able to reason things out. And that machines can't. The things like basically the lesson for generation of languages. So we actually spoke about how it evolved from non-portability, something that wasn't easy to use, I couldn't relate to now finding something now that by the click of a button, by just typing a word, it does everything. And this is how the language has evolved over the years. Now, question I want to put forward. COBOL. From what we have mentioned before, what generation, between what generation and generation do you believe COBOL falls?
Between 4th and 5th?
Close enough, 4th. As a matter of fact, between 3rd and 4th. Why is it 3rd and 4th?
Well, they said we can type a word and write some of the program for us?
Near enough, but that is almost the truth. In that it was very